Okay, let me do the second video on 11.4b. Here we're going to prove the limit comparison test. Okay, so if we got two sequences, AN and BN, which are both positive, I'm not saying which one's bigger, I'm saying they're both positive, and if we have that the limit as n goes to infinity of AN over BN equals C. What does this mean? That means after a while, this thing right here gets closer and closer to C, and then C has to be a positive number. So we put this on the number line. Here's 0, and after a while, this thing gets really close to C. So that means after a certain n, everybody gets mapped in some interval around C. Now, since C is bigger than 0, I can find some value, I'll call it little m, and some value big M, such that since after a while, AN and BN, AN divided by BN is inside there if n is greater than some number, say big N. After a while, all of these guys will get shoved in this interval close to C. So what does that mean? After a while, m is less than, little m is less than AN over BN and less than big M if little n is bigger than n. Now, so after a while, what I can do now is I can multiply both sides by BN. So I got little m times BN, and I'll get that a positive number, so I don't have to worry about flipping since inequality, is bigger than AN, is less than big M BN. Okay, you know, when you're dealing with series, it doesn't matter what happens with the first set of terms. You can throw away as many as you want. What you're worried about is just the tail end converge to something. Because the first 50, you can figure that just got out of 50 numbers. First 100,000, just add up her first 100,000. It's what happens at a tail, because that's got an infinite number in it. So after a while, after n's bigger than m, this is going to happen. So now, what do we know? We know the summation n equals, wherever you want to start, we can say n here, to infinity of little m bn. That's going to be less than the summation n equals n to infinity of an is less than the summation n equals big N to infinity of big M bn. Now, so if this happens, I can get all my guys in here for large enough n, and then I can make this inequality, and knowing that, I know that I got this inequality on the series. Now, looking at that, what if the summation of BN's, what if the summation of BN, n equals 1 to infinity, blows up? Well, that means its tail end's got to be big. So you're going to know that starting to get n, that's going to blow up. So suppose this guy blows up. What happens? You multiply it by a number. Multiply by a number. If this blows up, that's just multiplying infinity by a number, which is going to be another infinity. So if this thing right here blows up, that's going to make this guy blow up. So if BN blows up, that blows up, which forces this to blow up. So if BN blows up, the summation of AN blows up. Okay, now let's suppose that this right here, instead of blowing up, converges. So suppose this goes to a number. If this goes to a number, then where's this going to go to? That's going to go to, m's a constant. That's going to go to there's a bunch of additions, so I can pull the constant out. So that's going to be a constant times whatever this number is. So if this guy converges, this guy converges. This is a monotonic increasing, its partial sums are monotonic increasing. And so if this converges, this caps this guy, a monotonic increasing sequence, which is the partial sums, has to converge. So if this guy converges, that converges, which makes this converge. Okay, so let me put all that together again. So if BN blows up, then this has to blow up, which makes that blow up. So AN and BN have to do the same thing. Suppose that BN converges. If BN converges, then M, big M times BN also converges. That's bigger than this guy, which makes this guy converge. So that's the proof of this is a limit comparison test. So if you got two sequences, both of them positive, if you take their limit, divide the two and take the limit, it goes to a number bigger than zero. Bigger than zero is important. If it wasn't bigger than zero, then I couldn't get little m and big M on both sides of C. If C was zero, I can't get a number over here that's positive, and it's a screw up inequality. So both these guys gotta be positive and has to go to a positive number. Okay, if that's true, then whatever AN does, the series AN and the series BN have to do the same thing. And again, just like the limit test, you have to know something about one of them. Okay, I'm gonna stop the video here and we'll do some examples next time.